7.6 proportional lengths. Considering the diagram to the right, we see that these two triangles are similar by AA. So the triangles are similar by AA similarity. What is the scale factor? Scale factor is 2 is to 8. So it's just 2 is to 8, which we can simplify as 1 to 4. So how do we solve for x? Well, we can set up a proportion that the small triangle is to the big one as the small triangle, which is 3, is to the big one. Left, left, right, right. Cross multiply, we solve, we get x equals 12. So now let's fill in the pieces of this triangle. Well, this is 2, and the whole thing is 8, so this leftover must be 6. This is 3. The whole length here is 12, so this leftover is 9. Notice that the pieces, put a star here, the pieces of the sides are also in proportion, not in the same proportion as the original triangle. The pieces of the sides are in a proportion as well. Again, it's not 1 to 4. We'll see. The pieces of the sides are also in proportion with different ratios. So let's look. So the proportions of the pieces of the sides would be 2 is to 6. Whoops, 2 is to 6. And 3 is to 9. And those are all 1/3. So now when we solve, let's do this theorem. A line drawn through a triangle parallel to one side, will divide the other sides proportionally. Okay, so now we can use this new theorem when we have a triangle set up like below. So notice we have parallel sides, so we know the triangles are similar. So we can set up a proportion to solve x and to solve y. Why do we solve y first? Just because we just learned this theorem. So we would set up that y is to 2y plus 3 as 2 is to 6, which by the way is 1/3. But we'll just keep this. So we're going to get 6y cross multiplying is 2 times 2y plus 3. Don't skip this step. And then we distribute the 2 to get 4y plus 6. Subtract 4y from both sides. We get 2y equals 6 or y equals 3. So now to do x plus 3, now this is the bottom of the little triangle, the bottom of the big triangle. Now for this one, we have to use like the side. In other words, we'd have to say like 2 is to x plus 3 as 8, which is the entire triangle, is to 16. And we do the same cross multiplication. We get 32 equals 8 times x plus 3. 32 equals 8x plus 24. Subtracting 24, we get 8 equals 8x, or x equals 1. So we get 3 for y and 1 for x. Looking below, we have parallel lines. We have proportional sides. You could actually almost finish off this triangle if you wanted to, but basically it turns out that the proportion of 2 to 8 would be the same as x to 12. Cross multiplying x equals 24, 8x equals 24, or x equals 3. Okay, turning the page, we have one more theorem, and that theorem says that 3 or more parallel lines will cut any transversals proportionally. Three or more parallel lines will cut any transversal proportionally. So here are some parallel lines, here are two transversals, and so these are going to be proportional. So this is going to have a lot of x's in it, so we have to be very careful foiling, writing steps, not skipping steps. So we would get x minus 4 times x plus 3 equals x minus 2 times x minus 1. And we carefully FOIL, or multiplying all the terms, plus 3x minus 12, negative positive is negative, x squared minus 2x minus x plus 2. Putting it together, we get x squared minus x minus 12 equals x squared minus 3x plus 2. The x squareds cancel, and we can add 3x to both sides, and we'll get 2x, and adding 12 to both sides, we get 14. So the final answer for x is x equals 7. Here's what's called the angle bisector theorem, and this is an interesting proof. So if we have triangle ABD, C is on BD so that AC bisects angle A. That would mean that this angle, to bisect an angle, means that this angle here, BAC, is congruent to CAD. So it turns out that if these two are congruent, that I'm going to write it in words. If a ray bisects an angle, what is going on here? If a, what is it doing? Oh, I see. If a ray bisects an angle in a triangle, it divides the opposite sides. It divides the opposite sides into segments proportional to the other two sides. And I will show you what that means, and we're just going to do an informal proof. We'll prove it, but using this structure here. If it divides the opposite side into segments proportional to the other two sides. In other words, if these two angles are congruent, then AB, which is the left side, is to AD, which is the right side, as BC, which is the left side, is to CD. Now, you could also write it, because you know the top, top, bottom, bottom proportionality, you could also say that AB is to BC. Whatever, you could pick which one feels better to you. AB is to BC as AD is to CD. So here's an or. You pick one of these two. All right, so why is that true? So what we're going to do here is I'm going to do a little bit of construction, and we're going to make a line. We're going to extend D to be parallel to AC. And we're going to extend this triangle. So now we have two triangles. We'll call this point E. So we've made this parallel and this parallel. And notice that triangle ABC and triangle EBD are similar because of AA. If I call this angle 1, angle 2, angle 3, and angle 4, let's see. We know that angle 2 is congruent to angle 3 by alternate interior. We know that angle 1 is congruent to, angle 1 is congruent to angle 4 by corresponding, but we know that 1 and 2 are congruent by the given. That was part of the original statement. So if 1 and 2 are congruent, that means angle 3 and angle 4 are congruent by transitive, which means that this segment here is congruent to this one by ITTC. And we can set up right now that A is to B, A is to B as A is to E. We just learned that proportional lengths of parallel sides, and BC is to CD. But we've already established that AD is congruent to AE, so we can substitute, we can switch or substitute AE with AD. So we'd have AB over AD equals BC over, this should be CD. So this up here should be CD. That's why we always make our notes in pen. BC over CD. So notice this one is the same as what we did in the beginning. Okay, so for practice, right now, I want you to do 5A and 5B, and we'll go over the answers next class. Actually, I think I'll set up A. So notice that these angles are congruent, so that would mean that X would be to 6 as 12 would be to 10. And you can solve that. And I'll let you finish all of B and all of A.